Okay, good morning everyone. So in this video, I'm going to show you how could we do revision on this topic, electricity, which is in the integrated science, topic 8. I hope this video will be useful for you to prepare for your examination or test. So let's start with this topic. It comes to condition of a complete circuit. So as you can see from the diagram here, in order to make the light bulb on, you need two simple things. With the first thing, you need an energy source. It can be a battery. And then you have to connect the circuit in a complete loop such that the bulb will be turning on, or this is what we call complete circuit. And next, you are required to recognize different kind of circuit symbols as shown here. So for example, we have got here the left one is the battery, and please note that you are not required to write down the positive and the negative when you draw a circuit symbol. The positive and the negative is for you to know that the longer one is positive and the shorter one is negative. And we do have another symbol to represent batteries. If you've got a lot of battery, rather than just one, okay, if you've got 3 or 4, then you can actually have a dot line here to show the battery. And then we have got a light bulb. This is the symbol of light bulb. And next, we have got the switch. So with the switch, okay, we can also show the turning on or off of a circuit. And then we have got a voltmeter and ammeter, and once again the voltmeter and ammeter also have the positive and the negative side, and you are not required to draw positive and negative side in a diagram. And then let's talk about here is the rectangle one. The rectangular one is about resistor. So if we have a resistor to a circuit, and then the current will become smaller. It depends on how great the resistance of in a circuit, and then the current will be affected accordingly. And next you'll see there's an arrow on the rectangle. So with the arrow here mean that we can adjust the resistance. So this is also what we call a rheostat, which we can vary the amount of resistance in a circuit. And next, we do have another symbol, and this one with a rectangle and then have a line passing through it. This is a fuse. So with a fuse, we can actually break a circuit if the current is abnormally high as a safety measures. Okay, and based on the simple idea, you also need to recognize about conductor and insulators. So with some common example, that metals is a electrical conductor, plastic is electrical insulator, wood is insulator, and graphite, or what we call pencil lead, is electrical conductor. And for pure water, distilled water is a electrical insulator. And table salt, the one you can find in kitchen, is actually electrical insulator. But if the table salt is dissolved in water, it will become an electrical conductor. Okay, and then it's about there are two kind of circuit, with one kind called parallel circuit, and then is the series circuit. So for the parallel circuit and the series circuit, you can see the difference in the way the light bulb is connected to each other. And second, you need to be aware of the advantage of this and disadvantage of these two circuits. The advantage of parallel circuit is that if one of the light bulb goes out, the other light bulbs could also goes on. And for the second one, with the series circuit, it is like if we have got one of the light bulb goes out, the other light bulbs will not go on anymore because it become an open circuit. However, if we do have a parallel circuit, the total current of this circuit will become greater, and that would also have some potential hazard if we have a lot of light bulb connect in parallel, and somehow the total current of the circuit will be very high, and this could come out some heating effect of current, and we'll talk about it later. And then we have to introduce about current, or we use a symbol I here. It is meant by the amount of charge passes through a point every second. It is measured by ammeter and with the unit called ampere with the capital letter A. And the direction of current flow is from positive pole of the battery to the negative pole of the battery along an electrical wire. So let's take a look with this picture of an ammeter. You can see with the black one and the red one. So with the red one, you can see the positive side is that you connect to the positive of the positive pole of the battery, and the negative is connected to the negative side of the circuit. And don't forget that whenever we find the current of our circuit, we have to connect the ammeter in series with the device. Okay, and then for the voltage, we have got the symbol V here, which is about the amount of electrical energy of the battery supplied to each charge. It is measured by voltmeter with the unit called volt. And once again, you can see this is the voltmeter. And how can you differentiate ammeter or voltmeter? You can also see the units here. The V stands for volts, the unit of voltage. And it also has the red and the black one with the same way connected as the ammeter. And then whenever we find the voltage of a device, we will connect the voltmeter in parallel to the device, okay, rather than connect in series. So you may need to recognize that for voltmeter will be connected in parallel, and for ammeter have to connect in series. Okay, and then it comes to resistance. So we have the symbol called R to indicate resistance, and it is about the size of the opposition to the current. So what it means is like if the resistance is very high, and then the current will become smaller. It is measured by ohmmeter, as shown in the picture here. You can see the unit ohm here. Or we can have a powerful measurement device called multimeter. Why does it call multi? Because we can find multi-parameter in a circuit. For example, the voltage, voltage, current, and also the resistance. And if we twist it to different points, then we can actually measure different parameters in a circuit. And for resistance, is also a quantitative way to measure how conductivity, how great a electrical conductor is. So for example, if we say metal is a good electrical conductor, it means that their resistance is actually very, very small. Or if we say wood or plastic is a good electrical insulator, so it implies that the resistance of wood and plastic is very high. Okay, and then it's about the relationship between current, voltage, and resistance. So for case one is that if the number of battery increase, the voltage will increase, and hence the current will increase. So I guess it will be the easier one. And how do we really come and experiment to find the relationship? Is that if we connect to an ammeter and then we just vary the number of battery in a circuit, connect in series to a light bulb, and then you can see the brightness of the light bulb will be increasing. And hence, at the same time, the ammeter reading will also be increasing if you connect more light bulb to it. And then it's about when a circuit is connected in this way, it is a series circuit. The current in every point here is the same. So why will this happen? Because for current is about the flow of charge in a circuit. And in this circuit, we only got one single path. So meaning that every point in this single path will be the same, and then the current in every point will be the same. Okay, and then in case 3, you can see the two circuits with one got 2 light bulb and another one got 3 light bulb, and the rest are the same. If we got more light bulb here, the total resistance will become greater, and then the brightness of the light bulb will decrease, the voltage across each light bulb also decrease. So what I mean is like if we have got 3 volts in the battery, and if we have 2 light bulbs, then the 2 light bulb is sharing the 3 volts, so each of the light bulb will have 1.5 volt. But now if we add one more light bulb, then the 3 light bulb is actually sharing the 3 volts, so each of the light bulb will be 1 volt. So resulting the light bulb will be dimmer than the upper one. And for the current, for the bottom one, the total resistance will be greater than the upper one, and hence the current passing through in the bottom one will become smaller than that of the upper one. Okay, and then for the case 4, it's like if we connect the light bulb in parallel, and we can see that the total resistance will become smaller. So why will this happen? Because if we have got more light bulb connected in parallel, the current passing through the 3 light bulb will be more easier and be more quickly to go through, and hence the current will actually increase. What am I saying is about the total current will increase, and then the voltage will actually remain unchanged in this 3 setup. So these 6 light bulb will have the same brightness. Okay, so in parallel circuits, you can recognize that the total current will be increased if we add more branches connected in parallel, and the voltage will become the same. And then let's come to case 5. So for case 5 is actually a summary of case 1 to case 4, and you may see the relationship. So let's say here, if it is connected in series, okay, you can see the current at every point in series is the same, which is 8, right? 8 ampere. And then in a parallel circuit for X and Y here, you can see that here got 3A, and then the total current is 8A, and then the current passing through Y is 5A. So you can also do mathematical calculation to find the total, or the relationship of the total current is actually the sum of the current in each branch. Okay. And then there's also some factors that will affect the size of resistance. So for example, the kinds of resistance, as what I just mentioned about different kind of electrical conductor will have different value of resistance. And then it's about if the length is greater, then the size of resistance will be greater. And if the diameter of the material is actually smaller, for example, in this picture, okay, if the diameter is smaller, the current will become greater. Okay. And for rheostat, we do have 2 kinds of rheostat. Okay, the first kind is what we call sliding rheostat, and second one is the rotary rheostat. So it is the device to adjust the size of resistance. And how do we use the sliding rheostat? Okay, is that you can see the sliding contact here can be adjusted length. So let's take a look for my cursor here. When the current passing through to Q, and then it will pass through to the sliding contact, and then go to the resistive track, and then go back to P. So normally we will connect the rheostat at P and also Q. And this is also similar to rotary rheostat, is that we can rotate the buttons so as to adjust the length in the rheostat to change the resistance, and also help to change the current. So, and then it's about short circuit. So based on this picture is that if we have a short circuit, it actually provides a very low resistance, and hence the current will actually, most current will actually goes to the lower resistance part, so making this part become very, very high current, and it will also cause some high heating effects. Okay, thank you. We'll continue for next video.